Hello, this is the code walkthrough for our weather agent LLM app. And this is the main file that we implement our logics. So the main functionality of our app is it's able to take a user input as a sentence asking about weather conditions, whether for current weather or weather in the future at a specific location. And we're able to process that um, question, extract the information out of it, and uh, uh, consult the external weather API and kind of return an answer based on the response of that API to give a user a feedback on the question that he or she asks on the weather. So this is our implementation on this problem. So as you can see, this is kind of a start. Um, this is the start of our implementation. So we use majority predominantly LLMs to kind of facilitate the whole process. So we need our model loaded up in Google on Google Cloud. So we need a project ID, the region, bucket URI, and also the API key for the external weather service. So all these environment variables are actually stored in the in .env file, which can be added to the this .example file and rename it. So once you have that loaded up, um, once you have that filled up, you should be able to load into the environment those variables. So after that, we simply initiate a Vertex AI instance to use as our kind of database for LLM. And after that, these are some of the UI components that we use that my teammate Karina will demonstrate you, which contains of a user sort of a select box for user for user to select which LLM model to use, and also a user input box for user to type their input into the question, and also a send button. And after the user clicks on that send button, we'll basically start processing on the input that the user gives, and give a response accordingly. And yeah, we instantiate an LLM instance here using the selected model out of the two models that we prepare, which is Text Bison and the Gemini Pro models from Vertex AI. And we're using one here, but we actually actively compare the two in the accuracy evaluation process in this notebook file, where we compare the accuracy of the two models using some predefined data, but which is going to be explained by my teammate Karina as well. I'm going to leave that out here. Suppose we use a single model here. So once the button is clicked, we start the process of generating a response for the user regarding the question asked. So suppose that a user asks a question. The first thing we want to do is to decide whether it's malformed or it's malformed or it's actually a valid question. For example, if it's unrelated to weather, we're not going to answer that And even if it does have something to do with weather, but there's something missing in the information, for example, the location and the time, or um, we're gonna remind the user to kind of fill up all the information required. So so we're sort of doing a classification task over here. We're asking the LLM to do that for us. So we wanted to like output responding codes. For example, one, if the question is actually valid, and which is related to weather and contains all the necessary information. And zero, if it's related but not uh, sufficiently contains all the information, and negative one if just unrelated. So to facilitate the LLM to give a more accurate answer, we'll give an example here as well. So yeah, so after that we use a prompt template to fill in the user input into our prompt, and ask the LLM to generate the answer for us, which is going to be one of the three codes. So we kind of switch up our execution flow over here based on the response code. If it's negative one or zero, we're going to prompt the user to enter a valid question respondently. Or otherwise it's valid, we're going to enter our main flow to kind of process the question and give a response. So the first thing I want to do after we get a valid question is to extract all the information, necessary information contained in that question. For example, enough which is the location and the time stamp contained in the question, because that would be useful for us to kind of consult the external API for the weather data. So we also want, we just want these two data, and um, yeah, so to but I guess the problem is sometimes users give like relative relative times, for example, tomorrow or 1 week later. So that's why we want to get the current time and sort of compute the actual requested time based on the difference between the two. So this is what we're doing over here. We get the current time, and we ask the user, we ask the LLM to generate a uh, not only the all the other information contained in the user input, but also the actual requested time by the user, the the absolute timestamp requested by the user. So yeah, over here we're just using another prompt to prompt the LLM to extract all the information requested, including the location and the time requested by the user. And the input variables will be the user input, and also the LLM will need to know the current times, the current timestamp too, in order to compute the absolute requested timestamp. And this is for the second LLM. And we're all chaining in order to kind of reach our ultimate goal. We're chaining multiple LLMs together. This is just the first one that we're chaining. So this one is going to output a query info string, like we specified here. Um, so you can pretty much say that our output is sort of standardized along the way instead of some random data. So we're actively sending for um, a structure to the LLM to generate. So once we get that string, um, we'll basically extracted all the information from the user prompt, from the initial user question, and well, we're gonna kind of use that information to consult the external website, the external weather API. So how we're gonna do that is there's pretty much there's a lot of customized processing going on here. So what we're doing is we're defining our own function and transforming it into a component in the LM chain. So we use the transform chain class here to actually um, kind of cast our function into a LLM component. So this function is going to take the query info string and process on it and consult the weather API and give and output the response from that API. Let's take a look at the function itself. So once we have the information query string that contains like the location and timestamp, um, we're gonna first of all load it into an actual JSON from the string, and we'll talk about the exceptions later, because these are the actually how we handle corner cases and hallucinations by the LLM. So suppose we successfully load this query string up into JSON. Of course, we're going to validate whether that's valid, whether the the loading is successful. So, if it's successful, we're gonna um, basically compute the actual requested UTC timestamp. Notice that we're doing these computations in UTCs because users could be in different time zones, and users requested location can have different time zones. So a best way to handle this will be converting everything into UTC time zone, which is kind of an absolute value for timestamp, so that we don't need to do all sorts of conversions between different time zones and deal with all that confusion. And yeah, so once we get the UTC timestamp, we feed the timestamp into the web API later. And another thing we need to do is to convert the city name into latitude and longitude, because the external API only takes longitude and latitudes as a sort of a API specific issue. So we consult so we use a Python library called GeoPy to kind of convert from the city name to its longitude and latitude, and we're handling multiple. We're handling another exception here. So if the city name doesn't exist, we're just gonna raise an exception telling the user the city name is actually not correct. And once we have all these informations, we're gonna get the weather API key and consult that API using the longitude, attitude, and the um, the timestamp that we just got, and from the web API. And suppose we successfully um, retrieve a response from the API. It's just gonna be in JSON, and we load it up, and that's pretty much what we're gonna return here. But in order to kind of visualize the answer, um, and also to improve the the interactability uh, of our UI, we also add a web icon, a weather icon that represents the actual weather at the specified location and time. If it's rain, it's just gonna display a little rainy icon. But that's not much to it. But yeah, after we display that icon, we're just gonna return the weather response JSON to our main flow, which is the LLM chain for the next phase of execution. So this weather response JSON is gonna be the actual weather information that the user requested. So all we have to do now is to kind of interpret that JSON into a readable sentence, and and just spit it out. So we're gonna again ask the LLM to do that for us. So naturally, the third prompt will ask the LLM to we'll ask the LLM to output a sentence given the user input question on weather, and the actual API's response as a answer to that question. So all that LLMs has to do right now is to kind of textify that JSON and summarize it to answer the user's question. So I guess an example of its answer. An example of the web API's correct answer or response will be like this. It outputs the longitude and latitude, and there's going to be a data field contains all the useful weather data, like the sunrise time, sunset time, temperature, and stuff like that. And we just want the LLM to summarize all these data and output a text version of this information. Yeah, and the output of the third chain will be our final output. So in the main flow, we just chain all these three LLMs together. Um, and yeah, so for the overall chain, the input is going to be the user question, and the output is going to be a texified actual answer to that question, outputted by the last LLM. So which kind of achieves our original goal here. And we also added a little um, a user feedback button, thumbs up or down to collect user feedback. And we're not actively implementing this, but this could be collected and fed back to the LM training process. I think it's called um, uh, uh, reinforcement learning from human feedback. So we can add this information into the training process to kind of um to update the loss function to kind of depend on the user feedback to in order to kind of fine tune the actual training process of the LLM. So that's pretty much the main flow of the code. Now let's talk about some of the corner cases that we handle um, through exception handling. Um, yeah, so there are multiple corner cases that we handle. Um, for example, if the user what if the user input in a city that doesn't even exist, or the user or the LM is kind of hallucinating and outputs a timestamp that is that is out of the usual range of time. For example, like 20 um at 25 p.m. or something like that, 25 o'clock and 61 seconds, something like that. And all these corner cases are, I think, gracefully handled in our code. Let's just walk it through. So all these corner cases are handled by exception handling. So the first example is going to be um, here. The if the query if the query info output by the first LLM which takes user input and output a JSON representing all the information extracted. If the query info is empty, we're going to raise an exception telling the user the query is kind of empty. And also, if we're just using this for reference, this is the so this JSON string is the output of the first LLM in the chain. So there could be a chance where, like I said, the date time field output could be kind of malformed. So we also have to handle that. So once we feed it into the second chain that this function um, does, uh, we're gonna check or validate the JSON um, to see whether all the different fields are valid, or or does the JSON even contain that field? If it doesn't, we're gonna raise an exception telling the user like the LLM JSON is malformed. So that is a kind of a handling of the hallucination of the LLM model. So the third one is going to be here. The if the city name of the user input doesn't exist, um, or the LLM is hallucinating and output a city name that doesn't exist, even if the user inputs something valid. Uh, the location given by the GeoPy um, library that translates from city name to location to latitude and longitude is going to be none. And we check that. If that's the case, then we raise another exception telling the user the city is actually malformed. And another one is when um, uh, the if the URL um, given by if the URL fed into the web API request is invalid, we're just gonna throw a request error, which is handled down below over here. So this happens when um let me see. This happens when the URL that we feed into the request is invalid, um, or the API itself is down and doesn't respond to anything, and uh, this exception is going to be thrown. So this is our kind of our handling of the API availability and um, uh, yeah, the API availability issue. And even if the API is responding, but if we put something that's out of the capability of the API, for example, we ask it to predict the weather out of the maximum range that it can actually predict. For example, like 4 months or a couple of years, it's going to return a JSON to us containing two fields. One is the code representing uh, kind of response code similar to HTTP. It's not going to be, it's going to be 400 class code. And another uh, field is the message containing the error message. For example, it's going to say uh, the the time you requested is out of the range of prediction. Use another one, something like that. So this is our handling um, of the case when the API is not going to be able to just handle the information that we request. Another thing is if the um, is when the date time extracted by the first LLM from the user input is invalid. For example, uh, like we said, uh, something like um, 25, 25 o'clock, something like that. The string parse time function is going to throw a value error um, uh, to indicate this scenario. So we're handling that down below. And all the other exceptions may be thrown by other functions going to be handled at the end. And we're printing the stack trace as well. And that's pretty much it for error handling and corner cases. So as you can see, we're handling pretty much all these corner cases gracefully. Hallucination and standardized output consistency is also handled by specifying a explicit format for the LLM, both in the first LLM in the chain. That's a JSON object, not JSON format that we specify, and also in the last Textify LLM, we ask it to specifically explicitly mention the temperatures, weather, and all these weather data, just in case it doesn't realize or neglect some of the fields. And we handle sort of the response latency and API reliability and availability as well, just like we covered using exception handling. So I think pretty much all the corner cases are handled here. And my teammate Karina is gonna cover the accuracy evaluation or the unit tests that we conduct on the three LLMs in our chain respectively using two models. And we do kind of plot a model. We do plot the model comparison at the end, and she's going to also um, walk you demonstrate the actual functionality. And I think that's all for the code walkthrough. Yeah, thank you.